Okay, class, in this lesson, you're going to learn to apply theorems about isosceles and equilateral triangles to solve various problems. So let's go ahead and get started. So in this theorem called the isosceles triangle theorem, as well as the converse, the theorem basically says that if two sides of a triangle are congruent, so we've got AB here and BC have the same length, then the theorem says that the angles opposite those sides, so angle A and angle C, are also congruent. Okay, so that's the isosceles triangle theorem. And then the converse basically says that if two angles in a triangle are congruent, meaning they're the same, then the lengths of the side opposite those angles, so side AB and side BC, have the same lengths. Okay, so those are the theorems for the isosceles triangle. Let's go ahead and apply this to the following example. And here we have to determine the value of x. Okay, so we want to know what this angle is. Okay, so according to the isosceles triangle theorem, we know that if both of these sides are equal, then the angles opposite them are also equal. Okay, so this angle is opposite this side, and we know this angle is 28 degrees, which means that the angle opposite this side over here is also 28 degrees. Okay, we also know, or at least should know, that the angles, all three angles of a triangle, add up to 180 degrees. So to figure out this angle, we would take 180 degrees, okay, and subtract both of these angles, okay, 28 and 28. So that would be twice 28 degrees, which works out to 180 minus 56 degrees. And the result here would then be 124 degrees. Okay? And we are told in this problem that this angle is equal to 5x plus 9 degrees. So we're going to set this equal to 124 degrees. Okay, so we'd say that 124 is equal to 5x plus 9. Now we can go ahead and solve for x first by subtracting 9 from both sides. All right, and when we do, we're left with 5x, and that's going to equal 135. Okay, because these cancel out. And now we can divide both sides by 5. And when we do, these 5's cancel out. And now we know that x is equal to 27. Okay? So that is how we solve for x. Okay, so let's go ahead and move on to the next example. Here we are asked to find the value of x again. Okay, now we know according to the theorem that because these two sides are equal, then the angles opposite them, so this angle here is opposite this side, and this angle here is opposite those sides, this side, because those sides are equal, then we know that these angles are also equal to each other. So then we would go ahead and set negative 4x plus 9 equal to the angle 8x minus 3. Okay, now we can go ahead and solve for x. So to do so, we're going to add 4x to both sides. Okay, and when we do, these cancel out, and we're left with 9 is equal to 12x minus 3. And then we're going to add 3 to both sides. And when we do, we're left with 12 is equal to 12x, and these cancel out. And then the last step we're going to do is divide both sides by 12. And when we do, those cancel out, and we find that x is equal to 1. Okay, so that is the answer for this problem. Okay, so let's go ahead and move on to the next example. We're going to use, again, the isosceles triangle theorem to solve for the lengths of all three sides of this triangle. Okay, the lengths of all three sides of this triangle. Okay, so first thing we should notice is that we have two angles that are the same. Okay, so according to the isosceles triangle theorem, if these two angles are the same, then the side opposite them, so this one here and this one here, are equal to each other. Okay, so let's go ahead and set them equal to each other. X plus 20 is equal to 8x divided by 3. Okay, first thing we're going to do is multiply both sides by 3. And when we do that, we get 3x plus 60, okay? We're distributing here. We got 3x, and then we get 60 by multiplying 3 by 20. And that is equal to 8x, because these 3's cancel out. Okay, then we're going to subtract 3x from both sides. And when we do, these cancel out. We're left with 60 is equal to 5x. And then we're going to divide both sides by 5. And this will cancel out the 5's. We find that x is equal to 12. Okay. Now, the reason we went ahead and solved for x is because once we have x, we can go ahead and insert x, or replace x with the value that we just solved, and solve for the length of this side. Okay, so the length of this side is going to be 6 times 12 minus 12, and that's going to give us 72 minus 12, which is equal to 60. So we know the length of side PQ is equal to 60. Okay, and then we can also use this x value to solve for the side PR. Okay, so I'm going to go ahead and just label this. This is going to be PQ, and then PR is x plus 20. Okay, I'm going to replace x with 12, so that's going to be 12 plus 20, which works out to 32. Okay, so we now know PR is equal to 32, and then QR is 8x divided by 3. We're going to replace x with 12, which is what we solved right here. Okay, and we're going to divide this by 3. So this is going to equal 8 times 4. Okay, the reason I did that was I can pull out, I'm going to pull out a 3 from 12, and so we're left with 4. And we pull out a 3 from the denominator, so we're left with 1. Okay, so then 8 times 4 is equal to 32 as well. And that we should have guessed, or we should have known from the theorem, because if this side is 32, which is what we solved, then this side should also be 32 according to the theorem. Okay, so then QR is equal to 32. So these are the lengths of all three sides of this triangle. Okay, so let's move on to the next theorem, okay, and that is if a line or line segment bisects the vertex angle of an isosceles triangle. So here's an isosceles triangle. Okay, this side is equal to this side, and we have a line segment that bisects, that cuts this angle exactly in half. And when it does, then this also becomes a perpendicular bisector of the opposite side, meaning that this angle is going to be a right angle. Okay, so let's go ahead and take a look at the next example. Here we are asked to find the angle of RSQ, okay, RSQ. So we want to look for this angle, and we want to know the length of PR, okay, the length of PR. Okay, so first thing we should recognize is that we have an isosceles triangle, right? PRS has a side PS, which is the same length as side SR, okay? And we also have the segment QS that bisects this angle. So we know that this is going to be a perpendicular bisector. Okay, so we can go ahead and notate that with this right angle. And because this is a perpendicular bisector, we also know that the length of PQ is going to be 4 because it is going to be the same length as QR, because this is a bisector, perpendicular bisector, so that means it cuts this segment exactly in half. Okay, so we know that this is an isosceles triangle, right? PRS, and we know that both of these sides are the same, okay? Which means that if this angle opposite this side is 31, then we know that this angle opposite this side is also going to be 31 degrees. And we know that the sum of all three angles in a triangle adds up to 180 degrees, okay? So if that is the case, and we already know that this is 31 and this is 90, okay? That means that the balance of the 180 is going to be, let's go ahead and do this, 180. We're going to subtract the 90 degrees. That's this right angle, okay? And so we're left with 90. And then we're going to also subtract this 31. And so that means that the angle is going to be 59 degrees. Okay, so this angle right here, this remaining angle is 59, which happens to be the angle of RSQ. So then the measure of angle RSQ is equal to 59 degrees. Okay, and then the next thing we are asked to find is the length of PR. Well, PR, segment PR, is equal to PQ plus QR. Okay, so this entire length is made up of this segment plus that segment. We know this segment, we figured that that was 4 already based on our label, and then QR is also 4. Okay, so then PR is equal to 4 plus 4, which is equal to 8. Okay, so PR is 8, and the measure of angle RSQ is 59 degrees. Okay, so the next theorem or concept is about equilateral triangles. Okay, this is probably the simplest concept to understand because in an equilateral triangle, all three sides are exactly the same, and because they are exactly the same, all three angles are equal to each other. The converse is also true. If you have an equiangular triangle, meaning all three angles are the same, then that means all three sides are the same. Okay, and we know that all of the angles in a triangle add up to 180 degrees. So in an equilateral triangle, all three angles are the same, and that value would only be 60 degrees because 60 plus 60 plus 60 add up to 180 degrees. Okay, so that's one of the unique natures of an equilateral triangle. So let's go ahead and apply this to the last example in here. In here, we are to find the angle measures in an isosceles and equilateral triangle. Okay, so we're told that if the measure of angle CBD, so this entire angle here, if that's 130 degrees, then what is the measure of angle BAD? Okay, measure of angle BAD. So step one is to find the measure of ABD. Okay, measure of angle ABD. So first thing to do is to recognize that triangle ACB is an equilateral triangle. Okay, so all three sides are the same. So based on the concept that we just learned earlier, if all three sides are the same, then we know that all three angles are the same. And the only angle that would make sense, since they're all equal, is that all of these angles are 60 degrees. Okay? So we so to find the measure of angle ABD, okay, ABD, we know that the measure of angle CBD is 130. Okay, so we're going to define this. Measure of angle CBD is made up of, or is equal to, okay, CBD is made up of CBA, measure of angle CBA, plus the measure of angle ABD. Okay, so this is CBA and ABD. Measure of angle ABD. Okay, so let's go ahead and replace these angles. CBD, we're told, is 130 degrees, and that's going to equal the measure of angle CBA, which is equal to 60 degrees, plus the measure of angle ABD. Okay, so we can go ahead and subtract 60 from both sides. And when we do, these will cancel out, and we'll see that the measure of angle ABD is equal to 70 degrees. Okay? Okay, so then step two is use the isosceles triangle theorem, and we're going to do that because triangle ABD is an isosceles triangle. We have this side equal to this side, and we're going to use that theorem to find the measure of angle BAD. Okay, so in step one, we figured out that measure of angle ABD is 70 degrees. Okay, so that means this is 70 degrees. Okay, we know that the measure of angle, I'm going to call this measure of angle A, plus the measure of angle B, plus the measure of angle D, add up to 180 degrees. Okay, we know that the measure of angle B is 70 degrees. That's right here. Okay, measure of angle, I should be more specific here. Let me go ahead and rewrite this. I would say that the measure of angle measure of angle BAD, not measure of angle A, because measure of angle A could be interpreted in a number of different ways. So the measure of angle BAD plus the measure of angle ABD plus the measure of angle ADB is equal to 180 degrees. Okay, now we solved for the measure of angle ABD. We said it was 70, so we can replace that with 70. So the measure of angle BAD plus 70 plus the measure of angle ADB is equal to 180 degrees. Okay, so if we subtract 70 from both sides, then this cancels out, and we know that the measure of angle BAD plus the measure of angle ADB is equal to 110 degrees. Okay, so let's take a look at this diagram again. Measure of angle BAD and the measure of angle ADB. All right, those happen to be opposite the lengths that are of the same same length, right? This length we're told is the same as this length, and this length is opposite angle BAD, and this length is also opposite angle ADB. Okay, since these lengths are the same, that means that both of these angles are equal. Okay, so if they're equal, then we would say that the measure of angle BAD plus the measure of angle ADB, which is the same thing as BAD, right? Because we just realized, based on the isosceles triangle theorem, that both of those angles are the same. We could say that that's equal to 110 degrees. So we have two of these, two of measures angle BAD is equal to 110. So we can go ahead and divide both sides by 2. This cancels out, and now we know that the measure of angle BAD is equal to 55 degrees. Okay? So that is the answer to this problem. Hopefully this made sense to you. If any of this was confusing, please go back to the beginning of the video and listen to this again. Thank you.